Hi everyone, in this video we are on page 2 of the solving packet. So for numbers 17 through 20, we are going to be solving each equation on the interval 0 to 360. So that tells us that our answers are going to need to be in degrees, but we won't need the plus 360k since we are within one rotation of the unit circle. Now on this first one, I want you to put a star by this problem. We see that we have a quadratic because we've got cosine squared, but the problem is we also have sine squared. Now we have two different trig functions, so we want to change it so that it is only one trig function. So I'm going to go ahead and just arbitrarily choose to put it all in terms of sine. Now how we will do that is by using a Pythagorean identity. So sine squared theta plus cosine squared theta equals 1. So if I want to replace cosine squared, we're going to solve for cosine squared and subtract sine squared from both sides. So I can replace cosine with 1 minus sine squared. So we'll have the 3 still floating in front as a coefficient, and then 1 minus sine squared theta. But we got to be careful here because when I plug that in for cosine squared theta, we need to enclose it in parentheses. And then we've got minus sine squared theta equals 0. So I'm going to distribute to simplify 3 minus 3 sine squared theta minus sine squared theta equals 0. And since I have two quadratic terms, but no other single term like just sine, we can go ahead and isolate these by adding them together. The negative 3 sine squared and the negative sine squared is negative 4 sine squared theta. And we're going to isolate by subtracting that 3 over to the other side, giving me negative 3. So to isolate the sine squared further, we divide both sides by negative 4. And we get sine squared theta equals 3/4. All right, folks. Now from here, when I square root, a lot of times students will look at this and go, hey, that doesn't look like it's on the unit circle. But remember, when we square root a fraction, we distribute it to the top of the fraction. So plus or minus rad 3 over rad 4, which is plus or minus rad 3 over 2. So sine theta is equal to plus or minus rad 3 over 2. So we're looking for where our y values are equal to positive or negative rad 3 over 2. So I've got a y value of positive rad 3 over 2 in quadrant 1, positive rad 3 over 2 in quadrant 2, negative rad 3 over 2 in quadrant 3, and negative rad 3 over 2 in quadrant 4. So I've got 4 solutions from this one. That would be 60 degrees, 120 degrees, 240 degrees, and 300 degrees. So those would be 4 solutions. So 0 theta equals 60 degrees, 120 degrees, 240 degrees, and 300 degrees. So folks, be very, very careful that you, one, include a plus or minus anytime you square root, and that you rationalize your denominators. So folks, moving on to number 18. On this one, a lot of times students see the sine theta and the sine of 2 theta, and they think, oh, I'm going to factor out a sine theta from both of those. Now folks, I can't factor out a sine theta from this because it's a double angle. So I want you to put a note that this is not the same as sine squared of theta. If it was sine squared of theta, I would be able to factor out a sine from both of those. It's also not the same as 2 sine theta, where I'd be able to factor out a sine theta from both of those. So sine of 2 theta is not equal to either of these, because if you try to take out a sine theta, it's like that leaves you with 1 and a problem because of the double angle. So what do we do when we encounter a double angle? We have to replace it using one of the formulas. Now, using the double angle for sine, it's sine of 2x equals 2 sine x cosine x. So unlike the double angle for cosine where there are 3 variations to choose from, here I've only got one option. So sine theta plus 2 sine theta cosine theta is equal to 0. Now, this is not a quadratic trig function, but because I have two different kind of trig variables, I've got sine and cosine, we are going to try to factor it by taking out a GCF. Now, before we factor it, make sure it's equal to 0, because that's the only way you can factor and use the zero product property. So now I can take out a sine theta, which will leave me with 1 plus 2 cosine theta equals 0. So now either sine theta is equal to 0. So where is my y value equal to 0? At a theta of 0 degrees or 180 degrees. There's part of my solution. And then the other part, we're going to set 1 plus 2 cosine theta equal to 0. So 2 cosine theta equals negative 1 divided by 2. So where is cosine of theta equal to negative 1/2? We're looking for when our x part of our coordinate is a negative 1/2. So that would be in quadrant 3 and quadrant 4. No, sorry, quadrant 2 and quadrant 3. So a negative x value means going this way. So that means quadrant 2 and quadrant 3. So a negative 1/2 would be 120 degrees. Negative 1/2 would be 240 degrees. So those are my other two solutions. So theta is equal to 120 degrees and 240 degrees. All right, folks, now moving on to number 19, we see that we have a quadratic trig function. And since I have both sine squared and sine, we won't be able to use square root, but we will need to factor it. But before we factor it, we're going to need to get everybody on one side of this equation and equal to 0. So I'm going to go ahead and move everybody over to the left side to keep that 2 positive. So 2 sine squared theta minus sine theta minus 1 equals 0. So using the x method or the AC method, whichever you like, 1 times 1 gives me 1, 2 times 1 gives me 2. If I need a negative sign, I need my 2 to be negative. So 2 times negative 1 will work. So then 1 sine theta minus 1, and then 2 sine theta plus 1. So don't forget to put your sign back in, because that's how you are factoring it. You're using x like sine. So now sine theta minus 1 equals 0, or 2 sine theta plus 1 equals 0. So sine of theta equals 1. 2 sine theta equals negative 1. So sine theta equals negative 1/2. So we're looking for where my y value is equal to positive 1, which is only at 90 degrees. It's the only place where my y value is 1. Then, where's my sine value or my y value equal to negative 1/2? Our y value is negative in quadrant 3 and quadrant 4. So where do I have a y coordinate of negative 1/2? In quadrant 3, 210 degrees, and in quadrant 4, 330 degrees. So 210 and 330. And remember, don't forget to include your degrees as your unit on these. All right, moving on to the last problem. Sine of theta, cosine of 2 theta. Now, before you're like, oh no, I have two different trig functions, should I try to take out a GCF right away? What should really be sticking out about this problem is that double angle. So cosine of 2 theta. Now, folks, for cosine, remember, we get to choose the variation that will help us the most. So if I pick the first one, that's going to put this in terms of sine and cosine and sine. So if I pick the second variation, that completely gets rid of cosine and puts it all in terms of sine, which is exactly what we want to do. So we're going to choose variation number 2. So 1 minus 2 sine squared theta, and then equals sine theta. So I replaced the double angle, and now I have a quadratic trig function that is all in terms of sine. So I've got sine squared and sine. Now, currently, this is a negative a value or in front of our squared term. So I'm actually going to move this stuff over to the left side to make it positive. So we want this coefficient to be positive, so we're going to move everybody to the left. So positive 2 sine theta, 2 sine squared theta, and then plus sine theta, and then minus the 1 to move it to the other side. So using the x method, 1 times 2, and then 1 and 1. This gives me 1, this gives me 2, and since the sum needs to be 1, we'll make this one negative and thus that one negative. So sine theta plus 1 and 2 sine theta minus 1. So either sine theta equals negative 1, so notice I'm skipping a step there. 2 sine theta equals positive 1. I do not recommend skipping this step if you have issues with signs. So where does sine equal negative 1? Or where do we have a y value of negative 1? At 270 degrees. And then solving the other side, we're looking for a sine theta of 1/2. So where do I have a y value of positive 1/2? In quadrant 1 and quadrant 2. And looking at my unit circle, we would see that would be at 30 degrees and 150 degrees. And those would be our 3 solutions. So folks, on the next page, as part of your homework, I am going to have you complete number 25, 26, 27, and 28, making sure that you're paying attention to the fact that it wants all solutions. This one in radians, this one in degrees, so use the appropriate units there. Don't forget to define what K is. And then we are going to go through one more problem together, number 44. So on number 44, on this one, we want to find all solutions in radians. So I'm going to go ahead and immediately define K to be equal to set of all integers. So K is equal to the integers. Our solution is in radians. Now, folks, before we get into number 44, if I have x equals 3, could I reciprocalize both sides as an operation, and would it still be true? Is 1 over x, the reciprocal, equal to 1 over 3? As I can see with corresponding parts, x would still be equal to 3. So I can reciprocalize both sides of an equation and still get something that is true. And it's based on how things work with cross products. So folks, looking at number 44, we see that we have secant squared of theta. So one trig function that is squared, so we can use square root to solve. Square root. So secant theta equals plus or minus radical 2. Now, the reason why I bring up reciprocalizing, if I reciprocalize secant, we get cosine. What happens if I reciprocalize the right side? We get 1 over rad 2. So we need to try to make this a rationalized denominator by multiplying by rad 2 over rad 2. So cosine theta equals plus or minus rad 2 over 2. So where is cosine equal to rad 2 over 2? Or where do I have an x value equal to rad 2 over 2? In radians, that would be at pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. So theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Now, why all this awkward space here? Well, that's because in addition to writing those radian angles, we're going to need to add 2 pi k to each of them. And folks, sometimes on the test, students will write 360k, but when you have radians, you have to add 2 pi k to find the coterminal angles. So that would be our solution for that equation. So folks, the last thing that we're going to cover in this video is the last set of problems I'm going to be assigning. So you are going to want to do hashtag all on the final page of this packet. So 45, 46, 47, 48, 49, 50, and 51. Making sure that you are carefully expressing your answers, and it looks like the instructions got cut off here. For these ones, you are to find all solutions in degrees. So all solutions in degrees. And that concludes our video over the trigonometric solving packet.